This is topic 5.1, arcs, semicircles, and central angles. Alright, let's start with some definitions. A central angle is an angle with its vertex at the center. It separates a circle into two arcs. This right here is called an arc. AC is an arc. Oops, it's a curved line for that one. And then, let me put another letter out here. If we're going to name the arc going this way, ADC is how you would name it. In a minute we're going to talk about the difference between a minor arc and a major arc. This one, the smaller one, is a minor arc, and this one's a major. The one in the center, the actual angle, the central angle in this one is angle ABC. But it does separate into two arcs. Here's a theorem. The sum of the measures of a central angle of a circle with no interior points in common is 360. So if you were given an angle degree, that kind of looks like, well, we'll talk about that in a minute. Let's go on. On this one, the central angle, when they just want you, when the instructions say to name it, that just means use the letters that name the angle. Since E is the center vertex, you can name it L-E-Y, or you could put Y-L-E. I'm sorry, Y-E-L. Just make sure that your vertex point E is in the center. The two arcs are L-Y. This is an arc. It's a piece of a circle. Your other arc on this one is L-U-Y. Now when you name a major arc or a minor arc, you could reverse the letters. If you wanted to name this one Y-U-L, you could, or this one Y-L, but they are describing the same arc. Okay, let's go ahead and talk about minor and major arcs. These two definitions. The minor arc is an arc with a measure less than 180, and it's named by only 2 points. For an example up here, the minor arc would be L-Y. On a major arc, it's an arc with the measure greater than 180, and it's named by 2 endpoints and then another point that's on the arc. So you do start and end with the endpoints, and then make sure you name at least one other point. So you'll always use 3 points when you name a major arc. If they ask for the measurement of an arc, it does correspond with the central angle. That's another way to say they're congruent. They will be congruent. So let's look at this first one. That's what this little M right here means. On example 2, let me move this up. On example 2, they want the actual measurement of PCM. PCM is the central angle, so it's 110 degrees. This little curve mark means they want the actual degree of the arc. When it has an M right here, it means what's the degree. It always corresponds, which means it's congruent to the central angle. Now the major arc here, because together the minor and major arc have to add to 360, if you start with 360 and subtract your minor arc, your answer is 250. This actually is the answer. 250 is the major arc. Okay, they're asking here what kind of arc is PM. PM is called a minor arc. How do you know? PM is the measurement of PM is smaller than 180. That's how you know it's a minor arc. If you ever have time, if you need more time to write the notes, make sure you put it paused before you turn the page, before you go to the next page. Alright, the next page there's a definition. Semicircles. Semicircles, it's an arc with a measure of 180. It's a half of a circle. It's formed when a diameter separates the circle into two arcs. It could be more than 2. I just decided to put 2 on this one. If you look at the first example, this diameter is dividing. This is a semicircle that starts from J, goes through A, and lands at N. So that whole length is 180 degrees. Alright, this first one, they're telling us that, look at the example. It says in circle E, AEN is 18 degrees. That means right here. I'm going to go ahead and write that in on the picture. JN is the diameter, and JES is 90 degrees. So let's go ahead and write that one in. So if the semicircle is formed by these two angles right here, this one would also have to be 90, because the sum of the two have to equal 180. And if you subtract 180 minus 18, 162 is the angle JEA, because it's the other half of the semicircle. Now when they ask for the arc, the measurement of the arc, AN has, the arc here has the same degree as the central angle. JA, the arc from here to here, we already figured that out, is 162 degrees. And JAS, now make sure when you start one like this, JAS, since A is one of the points between J and S, it's talking about the major arc that goes from here all the way around. So this one is going to be, if you add 162, 18, and 90, that's going to be 270. That's how you find the degrees when you have a semicircle. Okay, let's go on to example 4. FD is a ray that's tangent to circle O. So if it's tangent, let's go ahead and put our perpendicular, our right angle box is going to be from this radius to the point of tangency. So you can put that, you can draw that in. Alright, let's look at all these angle measurements. It might be a good idea when you see one like this that already has a few given angles to go ahead and fill in some of the other ones. Let's see if we can figure that out. Well, we don't have a diameter. Let me think. 90, 90. We can find this angle up in this corner, because in any triangle the sum of all the angles is 180, and 38 with 52 is 90, and 90 plus 90 is 180. So now you have all of these angles that create the vertex point O. So if you were to add 45, 90, 85, and 52, and then subtract that from 180, that gives you 88 for this angle. And if you want to check it, just make sure you add all of these angles together, and they should all equal 360. That's another way to know your angles. On AB, that's going to be the central angle 45. For AD, AD includes, now you got to decide whether you're going to go around this way or you're going to go around this way. Because they're only using 2 letters, that means it's a minor arc. So if you add these 3, since that's more than 180, you are going to just add the 88 and the 52. So it is the short one, so that's 140. AC, since it's only using 2 letters, it does not mean the major arc, it means the minor arc. So you're going to add 90 and 45. That's 135. BC, BC is this arc, and its central angle is 90. ADC, let me see, where's ADC? Okay, ADC starts at A, goes around through D and C. We know it's a major arc because it's using 3 letters. So you would add 88, 52, and 85. And that's 225. For ACD, you're going to add 45, 90, and 85. That's 220. For ED, arc ED has a central angle of 52. AE has a central angle 88. The measurement of DOF, that's a central angle. DOF, look at where it's going. It's going from D to O to F, and we did that a minute ago. That's 52 degrees. And then EOA, where's EOA? EOA, we did that one too. That's 88 degrees. Let me know if you have questions about that one. Let's go on to example 5. Okay, in this example, we're going to have to use a little bit of our algebra skills because they're using variables, so we're going to have to do some equations to solve this one. When you take all the arcs of a circle and add them up, they all add to 180. Let's write that down so you'll remember that. All the arcs add to 360. So that's really how we're going to work this one. Let's start with AB. Since AB is x, BC is 4x, DC is 2x plus 15. I'm not going to worry about the parentheses. And DA, the arc DA is 3x plus 15. You don't really need the parentheses. You can leave those off. 360 is the sum of all the arcs. So here's our algebra problem. If you notice, you have 1, 2, 3, 4 x terms, and if you add a 1x, a 4x, a 2x, and a 3x, that's 10x. If you add the two 15s, that's 30. See how we're now solving for x. If you subtract 30 on both sides, that leaves you with 10x is equal to 330, and then divide by 10. So x is 33. Now that we know what the x is, if you just substitute your 33 back in the problem here, that means that this one's asking central angles. So AOB is the same as x. Let's go around here and figure out each one. This would be 33. 4 times 33, that's 132. 2 times 33 plus 15. Let me grab my calculator. 2, that's 81. And 3 times 33 plus 15 is 114. So that's how we know the degrees of each one of these. Okay, so let's look at the angles. AOB is the first central angle. That matches the arc at 33 degrees. BOC matches our arc at 132. Don't forget that the central angle is always the same degree measure as the arc that's made from that angle. So COD, that's this angle here, that was 81. And AOD was our 114. Now it's time to work on your own.